When we're making a map in 3D, one useful thing is that we can extrude various features on the map into the third dimension. And by extrude, we mean stretch them up based on some sort of height. So in this example here, we're extruding points so that they kind of look like tubes. So each one of those is a point, and this is showing that international passenger arrivals to Canada and the United States in 2007. And depending on how high they are, like New York is obviously the highest here, that would be how far up that point is extruded up into the third dimension. So points are one thing that we can extrude into the third dimension. Another thing we can do is we can extrude lines. So in this example here, we're showing a series of geologic cross sections, and each of these lines, represented by a different color, has been stretched up into the third dimension. It's still a 2D line, but the color of it has been stretched up into the third dimension to represent the varying thicknesses of these different geologic layers. Sometimes this is called a fence diagram because we're just kind of looking at the side of the fence here, but we're not actually looking at the entire 3D volume. Here's another example of extruding lines into 3D. This is the island of Maui in Hawaii, and what kind of looks like clouds here is actually contour lines of where how the rainfall varies across the island. And it does vary a lot across the island because we have the direction the wind is blowing. The direction the wind's blowing from is the rainier side, and after it crosses the top of the island, it doesn't have so much moisture in it, and it doesn't rain so much on the other side of the island. So what we've basically done is just taken those lines, hung them up in the sky so they look good, and then we've stretched each one of those lines out so it comes down as far. The further down and stretched, it indicates that's where more rainfall is occurring. So lines extruded into 3D. We can also extrude or stretch polygons up into 3D. In this map here, we're showing downtown Charleston, South Carolina, and we're showing how a rise in sea level would affect it. So the buildings are stretched up because even if the building footprint of the map is covered by water after sea level rises by so much, it doesn't mean the top of the building is going to be covered by water. That's just going to depend on the height of the building, how many stories it is, and that's what they're showing here. They're showing the building footprints extruded up into the third dimension, and then showing where there would be water around buildings, or maybe in some cases of smaller buildings on top of buildings, based on extruding those buildings up to their proper height. We can also extrude data up. So this map shows a population density map of the United States, and in the lower map here, we're extruding each of the counties up based on population density within the county. So we can clearly see places like Chicago and Los Angeles here, Seattle over here, and everything is extruded or stretched up to its proper height based on how high the population density is in those areas. This shows another example of extruded polygons based this time on median household income around the Detroit area here. And this is also a nice way of showing change because the polygon outlines themselves aren't changing, but over time the heights are changing. So here's the Detroit median household income where the richer households are in 1970. And then if we go to the next slide, here's where the higher incomes are in 2015. So these extruding polygons can be a nice way of showing change with time. And we can build things with these extruded polygons using building footprints. This is an example of a campus here where each one of these blue areas here represents some sort of, these numbered blue areas represent some sort of building. And then we're going to put in those building footprints, and then we're going to extrude those up in the third dimension. But we can see this is an AutoCAD drawing of the campus, and there's a lot more detail than just where the buildings are here. We see where individual light posts are here. We see where individual trees are in some cases. Fire hydrants are included on this map. All sorts of great detail that would be hard to make look good if we just extruded it, but I'll show you what we can do with that. In addition to that, we have aerial photographs of the campus, so we can even see like what direction cars are parked. We can align actual 3D objects on our model with how these cars are parked in the parking lots. And the end result would be something like this. So we see several different things here. We see things like sidewalks, which are polygons, and they're just sitting right on top of the terrain here. We also have terrain information contours here. But some features have been extruded up into the third dimension, like this fence line here. This fence line was stretched up into the third dimension in order to make it. All of these buildings here, depending on how many floors they are, have also been extruded upward. So, and they've actually been done 3 times like that. So first the building footprint was extended upward to give the red wall here. And then there's trim around most of these buildings. So another layer was put on top of that red layer and extruded upward again by a lesser amount. And then finally a green layer on the top and extruded upward again. So that's how these buildings were constructed in this 3D model. But you can also notice there's a lot of other details here, like the cars, the light posts, all these light posts here, the fire hydrants, even bus stops. And these are added as something that is called street furniture. And these street furnitures can just be added into a 3D view like ArcGIS, and then using a 3D analyst or using a 3D display, and then we can start building these things. So we're not only including the things that we've taken a lot of time to model, like the buildings here, but we can also include different types of cars. We can look for light posts that are similar to the ones that we see on this campus, and we can sort of just add all that stuff in, just like we're dropping it in, just like a point on a map. Except these things are cars in a parking lot. So there's a lot we can do with that, but here we're seeing both the buildings extruded and then other street furniture being added as well.